Okay, so now we're going to look at 4.3, which is more discrete probability distributions. We're going to look at two more. We have the geometric distribution and Poisson distribution. So many actions in life are repeated until a success occurs. For instance, a CPA candidate might take the CPA exam several times before receiving a passing score. Or you might have to send an email several times before it's successfully sent if you're having Wi-Fi issues. Some of us have been experiencing that a lot lately, which is fine. So situations as these are considered geometric distribution. So this is a discrete distribution. And let's say a discrete probability distribution. Of a random variable x that satisfies these conditions. Okay, our first condition is that a trial is repeated until a success occurs. Okay. The second one is the repeated trials are independent of each other The third is that the probability of success P is the same for each trial, which as long as we stay independent, that will hold true. And then the fourth one is that the random variable x represents the number of attempts before the first success occurs. Okay, so if we look at this and compare it with our binomial distribution, okay, we have two of our conditions are the same as binomial, okay, and that would be number 2 and number 3. Okay. With geometric distribution, what makes it geometric is the fact that a trial is repeated until success occurs, and that the random variable x is what represents when the first success occurs. Okay, so these are the same as binomial. Number 1 and number 4 are what make it geometric. Okay. All right, so the formula for geometric probability is actually, I think, in my opinion, the easiest. So the probability of the first success will occur on a trial, number x, is the probability of x equals the probability of success times q, probability of failure, to the x minus 1 power. Okay. The key thing here is there is no n because there is no fixed amount of trials. Okay. So remember, we are continuously failing until that first success. So that's why our failure is to the q minus 1 power. All right, so let's look at this first example. A cereal maker places a game piece in its cereal boxes. The probability of winning a prize in the game is 1 in 4. Find the probability that you. So from that, we know the probability of success is 1 in 4, or 0.25, which means Q, our probability of failure, would be 0.75. So win your first prize with your fourth purchase. So the probability of 4, okay, we're gonna have one success, so 0.25 times 0.75. Well, how many failures did we have? That would be our first, our second, and our third trial. So 4 minus 1, or 3. Okay. If you plug that in your calculator and you round to 3 decimal places, you get 0.105. All right, what if we want to find the probability that you win on your first, your second, or your third prize? So remember the word or means that we're going to be adding. So we're going to find the probability of 1, which would just be 0.25. The probability of 2, which would be 0.25 times 0.75. And the probability of 3 would be 0.25 times 0.75 squared, or 3 minus 1. Okay, so go ahead and calculate these probabilities. We get 0.188 for the probability of 2. And for probability of 3, we get 0.141. So the probability of 1, 2, or 3 is going to be 0.25 plus 0.188 plus 0.141, which is approximately 0.579. Okay. And then C, we want to find the probability that you do not win a prize with your first 3 purchases. So do not win, which is going to be 1 minus, because it's the complement of the probability of 1, 2, or 3. So 1 minus the probability we just found, so 0.579, which is 0.421.